Hi everyone, welcome back to my channel. So today we will be looking at this question, which is longest substring without repeating characters. So we are given a string S and we have to return longest substring without duplicate characters in the substring. So if this is S which is given, we have to return the length of the possible longest substring. So in this case, ABC is the possible longest substring without any repeating characters. So the answer is 3. So let's understand the question first and then we will look at the brute force solution and optimized solution. So given this input string, we have to find substring such that it is longest and it does not have repeated characters. So for this, we think about naive solution. We have a lot of possible substring from this. For example, this is substring, and this is substring, and till last, including A, we have a lot of substring. Then this is substring, this is substring, this is substring. So we have a lot of possible substring. For example, if we use A, B, A, B, C, A, B, C, A, B, C, A, B, C. So a lot we have, but if we look at this is a substring and there is no repeated characters. This is substring, there are no repeated characters. This is substring, no repeated character. This is a substring, but we have A as repeated characters. So this we need to ignore and we need such longest substring. For example, this length is 1, this length is 2 and this is 3. So 3 is longest till now. Like this we have to find the longest substring. So if we think of naive solution, first thing that we have to do is we have to find all the substring of the given string, and then we need to find that if the substring have unique characters in it or not, and if all the characters are unique, then we will store its length in our answer, and after examining all the substring, we will return our answer. So what we have to do in naive solution is find all substring, then check for uniqueness. We need to check that characters in the substring that we are choosing is unique, and then store maximum. So these are the things we will be doing in naive solution. So for having all possible substring, we will have a loop from I is equals to 0 to length of this particular string, and we will have an inner loop from j is equals to I to length of this particular string, and we will have a variable max length to keep track of maximum, and initially it has 0 value. Now what we will do is we will check if all unique, if the elements are unique in string S from I to j. I have already declared this function here, and this will check if the characters are unique or not in the string. And if they are unique, we will update our max length. So this will be max of max length or the current length, which is j minus I plus 1. And at last, we will return max length. Now, if I look at this function, what this is doing, this is taking an input string S and start and end, and it is declaring an unordered set which can only have unique characters. So this is an ordered set, and we are looping from start to end and checking the count of this particular character, and if the count is greater than 1, we are returning false, otherwise we are returning true. So this is the naive solution. If we look at time complexity of this particular solution, so this solution is running one loop from here, one here, and this is also running a loop to check for uniqueness. So this is order n cube solution, and the space complexity that we are using is order of 1. As the characters are limited in number, so this cannot grow infinitely. This will be a fixed length around 256 character is the maximum character that it can have. So this is a constant, so we will have space complexity as constant. Now this is not a really optimized approach. We need to optimize this. Now looking at sliding window optimization, so we need longest substring. So initially if we take this as substring and store our max length, then we add this particular element to the substring, and after adding we check if the substring still has all the unique characters. Yes, the substring has all the unique characters. So we will update this max length. Earlier it was 1, now it will be 2. Now next we will add this particular character to the window and check if the characters are still unique or not. Yes, they are unique. So we will update it to 3. Now we will add this particular character to the window and check for uniqueness. But we found that this and this, they are same characters. So this we cannot add until we remove this. So we will remove this character from the window. And after removing, we have this new window. This is also length 3. Now we will add this character, but on adding we check that this is already present. So we need to remove this particular character and move further. Now we will add this character to the window, and on adding we found that this is also repeated. So we'll remove this from the window and keep the window here. This is also length 3. Now we will add this character, and we found out that B is already present. So we need to remove this character also and this character also to include this B, because till here the substring has a repeated character, so this substring cannot be part of answer. Now we will add this, and we found out that B is already there, so we need to remove this from the window, and the current window will have this. And on doing this all, we will keep track of maximum length. So what we did is, we had a substring, and we kept on adding a character to the substring on the condition that the substring has all the character as unique. If any point we found that character are not unique, we will pop out the characters from the window till the duplicate character is removed. So we pop out till duplicate is removed. So this is the algorithm that we will code here. Now we will maintain a window with left and right index. For maintaining count of unique elements, we will use unordered sets. So in sets, we will push the character like A, B, C, and we will check the count of these characters. If the count is 1, that means that we already have this character in the string. So we need to know unordered set, the count function of unordered set, and erase function of this unordered set. And we will also insert in this set. So this is the prerequisite for this. We will have unordered set of character type. Let's name it ST. We will have a left pointer initially pointed to 0, and we will keep track of max length. Initially it is 0. Now we will loop through the string. Right is equals to 0 initially, as we will consider one character in the beginning, and right is less than s dot length, and right plus plus. Now we will check if our set already has this character pointed by right element? If it is already there, for example, it was A, B, C, A. So the set has A, B and C and we are trying to add A. So A is already present. So now we need to start a new window. We need to shrink our window. So initially the left was pointing here. Now the left will move forward. So we will do left plus plus and we need to remove this from the set because this thing is already done. Now we will remove this character from the set and add this further. So what we will do is, if this is already there, so in this case, if this is already there, we will do set dot erase the left character and do left plus plus. But if we use if condition, it will only remove this particular character. What if we have this particular condition that A is not in the front but in between, let's say here. So we need to remove this also, this also. So we need to use while here. We need to keep popping until we have removed the duplicate character. So we have now removed the duplicate character. Now what we will do is we will insert the right pointed character. Once we have inserted this character, we will update our max length. And at last we will return our max length. We have time complexity of order of n because each pointer left and right moves forward once only and we are traversing the string once only. So this is time complexity order n. And the space complexity is order 1 because we have only fixed number of characters. So we have only fixed characters, that's why this is not order n, this is order 1. So this was the solution. Let's code it on LeetCode. So let's code our solution. We will have a left pointer and we will have a max length which is initially equal to 0. We will have a unordered set of character type in which we will put our characters while scanning the string. Now we will loop through our string. So we will loop through our string and check if we have the right pointed element already in the set. So what we will check is while we have count of the right pointed string, while we have this count, move left further and we will erase. We will use the erase function and we will erase the string left pointed character. So this way we will pop out all the characters until the duplicate character is removed. Now what we will do is with this we have inserted the right pointed character and we will keep track of our max length. We will return our max length as our answer. Now let's run this. Let's submit this. So yeah, this was the solution. For more such videos on sliding window and all other patterns, please subscribe to my channel. Thank you.